They have stood here for 900 million years, and they are dying faster than any glacier, any reef, any rainforest on Earth, and almost no one is watching. The Norwegian fjords look permanent. That is the lie. From the air, they appear as wounds cut into the planet by something vast and indifferent. Deep blue corridors flanked by walls of ancient rock rising 6, 7, 800 meters straight from the water. Tourists photograph them from cruise ship decks and feel something close to awe. Scientists who study them feel something closer to dread. The rock that forms these walls is some of the oldest exposed geology on the surface of the planet. Precambrian gneiss, formed under pressures that would crush a submarine, crystallized when the continents were still assembling themselves into shapes nothing alive today would recognize. It survived 4 separate ice ages. It survived the retreat of the last glaciers 10,000 years ago that carved the fjords into their current form. It has now met something it was not built to survive: the chemistry of the 21st century ocean. Here is what is happening under the surface, and why it is almost impossible to see until it is too late. The North Atlantic absorbs more carbon dioxide per square meter than almost any other body of water on Earth. Cold water holds gas the way a sealed bottle holds pressure, efficiently, silently, invisibly. The pH of fjord water has dropped by 0.1 units over the last century. That number sounds trivial until you understand that pH is a logarithmic scale, and 0.1 represents a 26% increase in acidity. Right now, that same acidity is already dissolving the shells of oysters in aqua farms 100 kilometers from here. The farmers can see it. The shells come up, thin, brittle. Wrong. What is happening to a mollusk shell is happening, more slowly, to the oldest rock on the planet. Precambrian gneiss contains feldspar. Feldspar dissolves in acid. Not quickly, not the way limestone dissolves in a cave. Take a core sample drilled from a fjord wall in 1990 and a core sample drilled from the same wall today. Under a microscope, they are different materials. The outer 2 to 3 centimeters of the newer sample show crystalline degradation that matches, almost precisely, the increase in ocean acidity measured over the same period. The wall looks identical. It is not identical. The permanence is an illusion now. It just hasn't fallen yet. And all of this is happening in water that looks completely normal. Svein Harberg has fished Hardangerfjord for 31 years. His father fished it before him. His grandfather built a boat in a shed that still stands 40 meters from the water, the wood gray and salt-bleached, the tools still hanging on the wall inside. In 2019, Svein began pulling up nets with less than half the cod he had pulled 12 months earlier. He thought it was a bad year. The following year was worse. By 2022, he had reduced his fleet from 3 boats to 1. Catches across the inner Hardangerfjord have declined by 63% in 8 years, the equivalent of removing the food supply of 40,000 people and replacing it with nothing. The fish did not leave, they died. Or, more precisely, the thing they eat died first. Fjords operate on a biological logic that took millions of years to calibrate. Cold, nutrient-rich water flows in from depth along the fjord floor. Warmer surface water flows out toward the sea. This 2-layer circulation creates a permanent mixing zone at a depth of between 20 and 60 meters, the exact range where Arctic zooplankton feed, reproduce, and form the base of the entire food chain. Copepods, krill, amphipods, organisms each smaller than a grain of rice, collectively the most important animals in the North Atlantic. As surface water temperatures in Norwegian fjords have risen by 1.8 degrees Celsius since 1980, a rate 3 times faster than the global ocean average, that mixing zone has shifted deeper. The light required for phytoplankton to photosynthesize does not reach the new depth. The phytoplankton population in inner Hardangerfjord has declined by 41% since 2010. Without phytoplankton, copepods starve. Without copepods, the cod starve. Without cod, Svein Harberg counts what is left in his nets and says nothing. But what Svein can see from his boat is only the surface of something far larger underneath. Beneath the fjord floor lies a carbon store that climate scientists have only recently begun to measure with the alarm it deserves. The same cold, stratified water that makes fjords biologically unique also makes them chemically extraordinary. Organic material that sinks to the bottom does not decompose in the usual way. It is buried, compressed, locked away for thousands of years. Norwegian fjords cover less than 0.5% of the global ocean surface. They store an estimated 12% of all organic carbon buried in marine sediments worldwide. 12% in 0.5% of the space. Now the water is warming. Warming water carries more oxygen to depth. More oxygen means decomposition resumes. Carbon stored for millennia begins re-entering the water as carbon dioxide. The fjords are not just suffering the effects of climate change, they are beginning to drive it. A carbon sink is becoming a carbon source. The feedback loop has no natural break. In 2017, a research team from the Institute of Marine Research deployed sensors along the entire length and depth of Osterfjord, a narrow, shadow-filled fjord that does not appear on tourist maps, recording temperature, salinity, oxygen, and pH every 6 hours for 3 years. When they compiled the data, the lead researcher described it as the most comprehensive evidence of simultaneous multi-system collapse ever recorded in a single fjord ecosystem. Temperature anomalies, oxygen depletion at depth, acidification above every modeled projection, zooplankton population crash, rock surface degradation, all happening together. She had spent 22 years studying fjords. She said she had not expected to see this in her lifetime. What makes the fjord crisis different from almost every other environmental collapse on the planet is this: the failures are not parallel. They are sequential and mutually dependent. You cannot restore the fish without restoring the zooplankton. You cannot restore the zooplankton without restoring the temperature gradient. You cannot restore the temperature gradient without stopping the carbon input from the sediments. And there is no valve for that. No switch. No intervention at the scale of a fjord that any existing technology can perform. A researcher at the University of Bergen put it this way in a paper published last year. The system is not degrading. It is reorganizing around a new equilibrium. The old one is gone. Ingrid Solberg is 64 years old and lives in a house her great-grandmother built on the shore of Osterfjord, 204 kilometers long, 1,300 meters deep at its lowest point, deeper than the North Sea is wide. Ingrid remembers swimming as a child in water that was cold in a specific way, a cold that felt like pressure, like the weight of something ancient. She says the water now feels different, lighter. She cannot explain it scientifically. The scientists can. The thermocline, the invisible boundary between cold, deep water and warm surface water, has moved. The sensation she remembers was real. It was the physics of a system in equilibrium. What she feels now is a system that has shifted and will not shift back. Her son works for a salmon aquaculture company. It is the economic replacement for the wild fishery that her father worked. Salmon farms along the fjords of western Norway generate 400 billion kroner annually. They are the largest export industry in the country after oil. They are also, the science now shows, accelerating the crisis they depend on. Salmon lice proliferate in the warmer, more stable surface temperatures that climate change is producing, and require chemical treatment that alters fjord chemistry. Fish waste from densely packed cages changes the oxygen balance at depth. An industry built to replace a dying ecosystem is quietly hastening the death of the one it occupies. Ingrid's son knows this. He does not talk about it. There is no other work. The Norwegian government has committed to protecting 40% of its fjord ecosystems by 2030. The scientists who study those ecosystems say the commitment means almost nothing without addressing the chemistry of the water, which is determined not by Norwegian policy, but by global atmospheric carbon concentrations over which Norway, with its 5 million people, has no meaningful control. Norway produces less than 0.1% of global emissions. It is watching something irreplaceable dissolve, not primarily from its own actions, but from everyone's. The rock is weakening at the molecular level. The food chain is collapsing from the bottom up. The sediments are releasing carbon stored before humans learned to write. The communities that have lived along these waters for 50,000 years are watching a landscape alter in ways that cannot be walked back. The window in which intervention at scale remains theoretically possible is, according to the most optimistic projections, approximately 80 years. According to the least optimistic, it is already closed. Svein Harberg still goes out 3 mornings a week. He pulls the nets. He counts what is in them. He has not started teaching his son to fish.